There we go. All right. Now, let's talk about gates, and I'll demo that Simpleton in a bit. The book that you that's free for you is in the labs here, 273.
What file is that you have open for those list of commands?
This one?
Yeah, no, the one with the list of commands.
The what?
The one that has the list of commands on there?
Oh, these over here?
Yeah.
That's the same page.
Yeah.
It's all, yeah.
You said we were gonna go over these commands in class.
Yeah, we are.
Which one?
We're gonna do all kinds of fun things tonight. But this is the book we'll be using.
Oh, okay.
That's our textbook for this semester, because we are going to learn about the Raspberry Pi. I have one up here and I've got a few others. But one of the things we'll be doing is cross-compiling. So you'll be on an Intel machine. You'll take your C source code and then we will compile it to run on a foreign architecture. It's called cross-compiling. And it's something that you'll do in industry. And the debugger, you're gonna have to know the debugger. That's just, there's all kinds of debugging tools out there. But to start with, the reason why I wanted you to play with the origami is that these gates that we talk about, and I'm going to use this one down here. And bring that up. This circuit verse. And for example, what do we got here? Your homework says, I want truth tables for your exclusive OR, your AND, your NAND. Well, what are those truth tables and how do we figure them out? Which is why I gave you the origami stuff, okay? These are the gates. These gates are basically a combination of transistors, but the way these work is when you have a gate, and how do we get our outputs? Well, if I have a 1 and a 1, well, then I'll get a 1 over here. But if I have a 0, a 1 and a 0, I'll get a 0. And if I have 0, 0, I'll have a 0. And if I have a 0, 1, I'll get 0. So there's my truth table. Okay. So these gates are what you're learning in discrete structures and that sort of thing. And I have a few things we'll put on this. For example, a very simple way to do these is that I will write the truth table for the AND and OR on the board. And the way this works is that they have their symbol. Now, you're saying, why do I need to know this? Because it's all part of the computer. Well, it's the pieces that we'll be playing with is when we store 1s and 0s, they trigger things. When you run your code, it does things. And that's kind of what we'll talk about. So this is an AND gate. So basically what we'll do is we'll call this your X and your Y. So we create a truth table that looks like this. Here's my X, here's my Y. So I can do 0, 0, 1, 1. These are my inputs. And then I can do 0, 1, 0, 1. And then the output is simply going to be 0, 0, 0, 1. This is for an AND. And what I want you to do is go look up the truth tables for the other one, the exclusive OR. You got a list right there. You can Google them and find out. But this is what I want you to do, to create the truth tables. So 1s and 0s. the next thing I'm gonna do is show you what happens on disk with some of these. Let me bring up my, let's see here. Okay, I'm gonna open a terminal. And I'll just do it here. All right. Now, I'll sit down here. You know, I should just do screen share and not even use the camera. They don't need to. You will find that last week's video was posted. So it takes me a day or two to get it posted. I'm recording today because I had 2 students say, hey, I can't make it. Can you record it? So unless I hear from you, I'm not going to record. Okay. So if students say, hey, I'm going to miss class for some reason. Okay. So let's create, I'm going to do something in here. This is called VI. This is an editor. Okay. And I want to show you what happens, and I'm going to call it hi.txt and just put in some data. Now, if I do this, do %, what happened? These are your ones and zeros. This is how data is stored on disk. Or is it? How is data stored on disk? On an aluminum substrate, it's ones and zeros. It's magnetic flux. But when we look at code, we don't read ones and zeros. We take the group of 4 bits for our hexadecimal, that binary decimal hexadecimal quiz that I give every semester. So 4 bits gives us the values from 0 all the way up to F. Everybody know how that works? Or is this blank stares? Is it? You enlighten me, right? Yeah, this is part of what the binary hexadecimal quiz is. So if I have 4 bits and I have 0, 0, 0, and then I go all the way down to 1, 1, 1, hexadecimal means we have 16 places. So we start from 0 and end with F. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we use A, B, C, D, and E down to F. So when you look at data on your disk drive, that's a little small, it's all in hexadecimal. But on the disk, it's ones and zeros. Okay. But we see things in hex, and we will be very comfortable with hex by the time we're done with this class, because we poke around on our object code with the debugger. Okay. We'll do all that fun stuff too. All right. So there's the and then the or. And these symbols are pretty standard, although I believe they are. This is pretty simple. So we'll have the same pattern. We've got 0, 0, and then we have output. We have 0, 1. So this would be my truth table. So this would be X, and that would be Y, and that would be Z. Here's Z. So these gates, you can build your own computer using these gates. And how many have heard of the maker community or make? You know, right here, this fellow, open source hardware, burn your own chip using logic, and you can make your own chip. You can use field programmable gate arrays. You can do all sorts of things. But all these ones and zeros are tied to the transistors. We have 4 billion in our iPhone. So when we start putting together these gates, we have these symbols that we use, and we call it Boolean algebra. Okay. And I'll show you what that looks like. Again, it's just another link over here. Here's truth tables, Boolean to logic gates. Okay. If you get into hardware design, so you can actually, there's your Boolean algebra. You need this for discrete structures. And then this is how you could build your chip by putting together these gates. We're just to talk about this stuff up at the nebulous. When we get down to the nitty gritty, it's going to be ones and zeros. It's going to be hexadecimal. It's going to be in the debugger. And that's kind of how we're going to work with things. Okay. Now, I do want to go to this next piece for you. So I'll go ahead and just exit out of this one. The lab that we'll be doing here is not what we actually get to do this. Oh, I did want to show you this one. This is a student who learned NASM. We have NASM and MASM and AS, and we're going to talk about all the different assemblers and what they do. But this student wrote how he learned it. This is an example of a learning log, whatever you want to call it, but this is a great portfolio piece saying this is how I learned assembler, or this is how I built my own website, or whatever. But this is the kind of thing you're going to need to get the job, because you have to prove you know what you're doing. It's not just a degree. Okay. So that's actually kind of a nice looking thing. So I will walk through this one here, and then okay. This is the C source code. Remember from last week? Remember how we did that? And we compiled? Let's do it again. This time, you just copy this whole piece of code onto your computer. And you remember how to do that? Ancient history. There's a couple different ways to do this. But do Control A, right click, copy. And then over here, I'll put it in my C++ directory. I don't have C++. I'll make a C++, make dir C++, change directory C++. It's all right. We're going to show you. And I'm simply going to call it Simpletron. Now, what is this doing? This is taking standard in and redirecting it to the file. Okay. I hit enter, hit Control Shift V, and then Control C. There, I now have my file.
Go back to the top.
What?
The first line of code is at and what text file?
Yeah, the text files from the link over here.
talked about for the code vector, it's cat, base type C++ source for the text file, after you cat, the dash. and then-
Oh, yeah. History. It's cat space minus space redirect, and then the name of the file that you paste your source code in. And yes, you're going to be learning about the command line. That's where all the good jobs are. So now that it's there, I'm ready to compile it. And that's pretty simple. Now I put that in the right here. So if I just open this over here, oops. Here's the compile line. Okay. Now what does this do? It says take the G++, this is our C++ coding, and that's the name of the file. The -O is the output. And then I do a colon, which simply says run it. Okay, so I'm putting two commands on one line separated by a semicolon. So now I can do that. And it, oh, I got an error. Why do I have an error? Well, there's a missing something. So let's go take a look at it. Line 259. Yep. Didn't have the. All right.
So what line did you fix? Those little
What?
cat- What line do we have to fix?
You don't have to fix it. I just pasted it wrong. It depends on how well you did your copy, cut and paste if you added noise. Okay. All right. Now, what are we doing here? This is what we're going to step through. Once we get this up and running, we're going to step through this very first question for this. What we have here is a piece of code that came from a C++ programming book that created a CPU chip in code. And we're going to be typing in assembler, so to speak, into this to see what happened. And the next piece is this one, where you have the instructions. Okay. Now it's explaining the code and everything. What we will do tonight is just this part. Okay. What we're doing is that this is our location of memory addressing. Okay. And then these are the actual commands using signed integers and unsigned integers. Okay. So now that I'm ready to do this. Well, what am I going to do? Well, this is, I will bring up, I'll move this over here. And then this is basically what I'm doing is I'm going to be typing in that +1007, which is on that piece of paper. And I'm just going to key these in just the way they are, and we're going to see what happens. Okay. And this is probably what we'll spend the rest of the evening on. And then you will do the other one. So once I put in my 7 there, or 107, move it over here. And then I just hit enter. Now I'm loading. I have incremented my counter, and my memory spaces are being allocated by how many bits? Yeah. So each time we move, we put in our data, we have to move it over by the same amount. Like in the world of Python, you don't have to worry about any of that. In assembler, you worry about address spaces. You have to the segment and the offset. We'll learn how to do all that. Okay. So now I'm going to do plus 1008. And then it says the commands, your walk. And then I'll just 7. Number 3 is, and this will be one of your labs, and then you just screenshot it, and then I'll show you what happens when we get it running.
So what exactly is the 1,000, so 7,800, 2,007, and so on?
You're gonna have to yell.
What is all these numbers that we're typing in?
That's what the homework is about. In the instructions and in the source code, it explains why these are the way they are. Because we are actually, if we look at that, it says read A, read B, load B, add B. It's doing a very simple integer arithmetic calculation using our hexadecimal opcodes for our Simpletron computer. Assembler, right? Not anything very useful, but it's assembler. 4. And then I go down to number 5, where it's 9. 6 is plus 4300. This is the halt command. And then 7, 8, and 9 are all zeros. And then how do we stop? Oh no, it's still taking all my data. How do we get it to stop? We use a minus and 5 nines. That's in the instructions. Okay. So I'll put in the minus sign here. 1, 2, 3, 4, 5. Now watch what happens. Enter an integer. So by looking at the opcodes here, it's reading A, it's reading B, it's loading A, it's adding B, it's storing C and writing C, then it halts, and then it returns the result. Okay. It's very, very primitive, but it's enough to get it to work. Okay. So I'm going to enter an integer. And how big can integers be? Well, if you type a number that's too big, you're going to overrun the register and your computer, the code will just go bleh, it'll bark. Okay. So I'm going to use 6 and 7. Wow. What am I looking at? This is your future. This is like looking at the debugger. This is the data. Does that look like the commands we typed in? And notice it's got 5 bits. The leading bit is 0, not a plus sign, because we're using signed integer arithmetic. And we'll do how to do binary adding and subtraction as we do some of this stuff, know how it works. And it says, okay, look. So it took my 6 and a 7 and it added them. And it says, Simpletron done. That was a lot of work to add 2 numbers, huh? Yeah. Okay. All right. Let's see here. I don't want to get too deep on that part yet.
Oh, yeah.
Still has the word. So confused. Oh, shit.
Unterminated comments. Okay, so you need to bring it up if you're gonna insert that one.
Did you type in to dash it?
Simpletron. Your G. And scroll all the way to the bottom. See, there's a. Put a slash, hit the letter A.
Exactly. I did the same thing 3 times.
Now we did a
You're
snake,
supposed to face this one.
colon.
Did you face this one? This is the next one. This right here, yes, this is what we're gonna get to. And then from here. And then.
Colon.
Just.
Shift.
Like we just do.
You enter the G++ code right after you copy.
So I think the lab is this. This is a target.
Now, open.
When you just
That's
visit it.
it.
Yeah, so it's easy to get out. Yeah, the G++.
You can read it. That's part of the
That's the next step.
Tonight, scroll down. That's just like. Just those kind of wow. Yeah, we'll do screenshots. Oh, I need to show you how to do screenshots.
So what's happening is, look how when I make,
Mhm.
so
I don't
when
exactly know, are we doing it today here or is it?
the point of.
something we were-
Yeah, that's
What
what
we're
the
doing
turning
is
in.
we're actually creating.
So if you go to the
So
lab
you can be able
in
to see it.
Canada, you'll see I want two tables for the following gates.
Okay, so we're supposed to
And-
do that.
That file is what we're
Yeah,
trying to
you
get.
can just do that whenever. you want. And I'll-
When it's said right here.
Oh, sweet, thank you.
Yeah,
Yeah, because I was a little bit fuzzy on that.
yeah, it's like getting
What you name it?
assembler is really kind of a. I could start writing assembler code, but then you're not gonna know what it does, so we're kind of working our way toward it. Yep, it's undetermined.
So I was trying to get.
No, you're right.
So it was like, I'll just get Alpine ready today. And then I just
We're just saying, right.
you have access to like, pretty hard.
Yeah. You know what runs into it? Yes. I can't. There's only one. So basically I could do that. And the virtual machines.
I didn't mean to do that.
Then virtual machines. You got a lot of work on your head. It was I did it. It was
Oh, you did it.
literally.
But like in the long run, I feel like it's worth it.
Yeah, no, I have.
Shift season or something. Now, type in those. That's you have. Just unterminated comment. Oh, you need control C, not control C. But go ahead and bring it up. Yeah. M. State. WQ. Now hit up arrow. File again. There we go. type in the plain instructions. There you go.
Is that what we're looking for when I type it in?
Oh, look what happened is this down went further. Core dump. It panicked. So scroll up. So when you see, you tried, you got your prompt. And you go ahead and take control C. Things are all sit up arrow. Yeah, you can do that. Yeah, do that. Now, see how this is 0. Now you go to the instructions and you type in the line command. I'll bring them up on the screen. Oh, you have to escape. Escape, :W2. Remember, VI is a mode editor. We have an insert mode and a command mode. We bring up the. Those are the, once you get it working, punch in those numbers and see what happens.
Location or number?
You're gonna read the assignment.
Yes. Oh, yeah. 06.
Okay, I was sitting there like, yeah, I was gonna say after he did that.
Oh.
It's gonna work once you
And incorrect.
well, or whatever thing he wanted you to do, it did something, not that.
It did basically the same thing, but it shoved one in it all. I think is what happened, yeah, because you started out with control.
Yeah, let's let me throw this or something.
It's not, you're on the example.
You did it.
I did it right.
You did it.
I mean, it still shows up as correct.
Okay.
Amazing. Now you have your prompt. Good God, I don't care.
Your tables for all of those.
Not your babysitter. Okay, so for this assignment, for this lab 2, there's other pieces of code that you're going to type in. And I want you to read through the instructions and try to figure out, okay, I'm putting in these numbers, but some of these numbers are data and some of it is actual command. So when I'm saying add, well, there's opcodes in there.
So when you read through this, the instructions, it's not very long, you'll get this, to say, oh, these are the actual operands that make this processor work. So that's kind of. Okay. Oh, did you compile it? Yeah, that one. Yeah. Go ahead. Unterminated comment. We're all getting unterminated comments. What that means is at the very last line, it's not correct. See how it has a slash there? Is that here it doesn't? So on your.
Yeah.
To be fair,
It's not like I was.
Maybe to your next.
he said we copied it wrong. He didn't say why.
Really
All the way down to the bottom there.
It's gonna be.
I don't know, there's no terminating line.
That's just generally how these courses go. He just types in commands like instant. Yeah. Like, I wanted to know what those did.
Would have liked to see that.
Really got like.
I guess it's fine. At least in comparison to what other shoots were doing, where it was like. Talk to you vaguely about it for like an hour, and then you gotta teach yourself how to do it outside.
Yeah, I mean, I did all my CS stuff.
Yeah, it's good. This is my first.
And then when you get to 10.
Sidewalk sucks.
All right. Now.
It's gonna
Put in
be
your
a
command. So what you'll be turning in is your best explanation of what this is doing. Okay?
And by next week, you'll have a login to the Jeremy box so you can actually do this stuff. And it looks like we're gonna need to do a little bit more with VI because we're gonna have to edit code. And VI is the tool that everybody loves to hate, so I will torture you with it unmercilessly. It works well. All right, so all right. So fun. We got it sort of working, right? Now, what were the steps that we did? I gave you code, you copied it, you compiled it, you ran it, and you punched in the registers. Okay, that's all we did. And this is how it does its thing. Now, as you read through these, you'll say, oh, let's do this, let's do that. And these get longer and longer. And it's kind of cool because you're actually, when it's finished running, you can actually see the results get stored. This is going to be very similar to what we're going to see in GDB, with our debugger, when we start poking on code. Okay. And so does everybody got this sort of working? Yeah, because you'll have to do all the rest of them. So that'll be your homework. And I'm here at 4 o'clock. So you can spend some time before class or even after class to work on this stuff. And if you want to get, I don't know if Windows, I don't even, okay. You can go find somebody who knows Windows and put, I think C++ is part of VS Code. I don't know, that might work for you. This code is pretty generic, okay? All right, now, let's see here. Hmm. I better hold off on that. All right. Let's look at something. Our code ran and it stored stuff in there, right? We called the file Simpletron with no .cpp, did we? This is what we'll start to be working on, is the compiler switches that we will use to create or not create our assembler file. So what we're going to do is we have C source code, C++, but there's a compiler switch that turns it into assembler code. Okay. And that's what we're going to do next. And there's you might want to write these down. NASM. MASM. Then there's gas, and then there's AS. These are assemblers that work with different syntax. Okay. And let's see here. I think uppercase. That, folks, is your assembler.
Go back to the code you typed in, that's too fast.
What? I went too fast?
Too fast.
I'm notorious for going too fast. But yeah. So basically, I do the same type of compile, but notice I'm using this switch here. It's S. S, and I believe there is a, oh, I can't remember on C++. I'll have to check it.
Is it case sensitive?
Yes, everything in Linux is case sensitive.
What is the S?
It's the compiler switch to generate assembler code. So when I do this and I do an ls LTR thing, I got a new file. .s. What's in that? How do you look at a file? You can bring it up in the editor, or you can type in the word cat space simpletron.s. And it will go really fast. It blasts by. So you can use a vertical bar less here, so you can actually page through it. Now, we're going to learn how to read this stuff. Not very well, but this is how the debugger works. Your compiler, this is pretty much true for all compilers, does this behind the scenes. So it's actually turning it into assembler and then linking it. And what we'll be doing later is actually taking our .s file and changing it and then assembling it. So we're going to learn the steps of making our assembler code work. Now, notice these are all registers. There's zeros, there's hexadecimal in here. It's just like what you just did. These mean something. And if I was to do a .s on my Raspberry Pi, this would look very different because the Raspberry Pi is a different piece of hardware. We have Intel and ARM. They generate separate assemblers.
What's the code to open that? It's just the G plus plus Simpletron dot CP minus S, right? That's the only thing you use with them. That brings nothing up for me.
Are you in the right directory? Did yours compile? Did it run? Did you punch in your 9 thing? That did its thing? Okay, so it's there. So if you do G++, and I believe there's a difference between the lowercase s and the uppercase s. And I can't remember which one's which. One of them is a gas format. One of them is the NASM format. I can't remember.
Here, it doesn't bring it here, and just takes me to the next line. Like it did not.
Well, yeah, when you hit enter, it'll blip, right? That's what it's supposed to do. It created a new file called simpletron.s. So if you do an ls, you'll see your file in your directory.
Only using capital S is what gave it.
Yeah, either one. Yeah, there's a difference. The way the syntax works in the assembler, slightly different. Okay. So did you see it?
Yeah.
Okay. All right. So fun. Now we're getting a little more cooking with gas, I guess you could say. We're getting closer to what assembler is really about. And what we will be doing next week is also putting a file in. It's being very short. But this one you're going to type in because we're going to take another 15 minutes and do some VI editing so you can survive VI. Okay. Oh, what we're doing is we'll give you some shortcuts to get VI, survival VI. So to bring up a file, let's edit the .s file. Let's just bring it up, okay? Type in VI and then it's that simpletron.s. Okay. Just bring it up. There's your file. Now, how do we move around? Well, you can use the arrow keys, or if you're a gamer, it's HJKL. Those move like the arrow keys. So when we bring it up, it's there and we can move around. When we first bring up VI, it's in command mode and it won't change our file until we change it. Okay. So arrow keys. Now let's get in there and change it. Type in the letter I for insert, lowercase. And that will put it into insert mode. And you can change something, anything, add a comment. See if you can figure out what the comment is. Is there a comment in here? Not really. I don't see any comments. Yeah, just put your name in there. You can just generate it. So, all right, what I'm going to do is I'm going to bring it up. Simpletron.s. And, oh, that's what I'll do. I'll just change it here. I'll just change this. I'm going to change simpletron.cp. And I'm just going to use underscore my first name. So how do I do that? Well, I use the arrow keys to get right underneath the dot. Then I hit the letter I to insert. And then I'll do my underscore DKP. And now I want to save and exit. So we hit escape :WQ. Now do it again. We're using I for insert changing something.
And then we're using escape colon WQ to save and exit. Okay. Q. That's all you really need. Now, what you can do with VI is a lot. And if you want to get into security, you're going to have to know the command line, and you're going to be using VI. I'm sorry. If you're going to be doing a database and you're going to be running the command line, you'll be typing in SQL statements. Yeah, it's kind of important to know how to navigate the command line. Okay. And you can put VI on your Windows box. You just go to vim.org and install it. Because this is one of the tools that we'll be using. Text file is what your source code's in. And we're going to edit, move those things around. Okay. So I'll help each other around here and play on that a bit. Now, who has a Raspberry Pi at home? Anybody? No, really? They're a lot of fun. They're only about 35 bucks. They have a reasonable, they're not great, but they're fun. The Raspberry Pi Zero, I believe, is $5. So they're very inexpensive. Yeah. Oh, need some help? Oh, escape. Oh.
Yeah. No, not enter. And then just
Yes.
use it.
Very good. Escape.
Colon WQ.
So now,
Yeah. Escape. Shift colon. WQ.
you did it. I'll do it a couple more times.
Oh, yeah.
Also do,
It didn't work.
here,
Type in history. See what happens. Yeah, this right there.
So you try to.
So what you gotta do is copy that.
And I would want to do like some projects to keep myself up.
Yeah, you got it down. Now try to compile. Just do it.
So I think what you need to do is like this.
And- But you need the one with the dash O.
Someone see if the dot is left.
Okay, that's all right. Let's do that.
So you have to do that.
That's okay.
So.
Yeah, just do it now. So where's your .s file? There.
Also, I think it would help if you make a CPU folder.
Oh, so you don't have that. And there. Yeah, the uppercase S, lowercase s, there's some subtle differences. But one of the things we have now, we compiled our code, right? So I have our English text that takes our C++ source code. We compile it into object code. Okay. Then if I do all right.
Did you just put Simpletron or Simpletron dot src?
No, I'm looking at the object code now.
Lost all along that?
So help. And look at all this fun stuff. This is the debugger. This is how we look at the hexadecimal object code. And we'll be doing that next week, okay? So this is, get comfortable with this. And I've got a ton of references over here on the debugger. Okay.
What is JB? Or GB?
That's GB.
No, just press W.
The GNU debugger. It's the debugger. Okay. And there's a bunch of them there. And we will do some very minimal stuff in the debugger. But we're going to learn enough. Okay. All right.
What was in the GDB House of Horrors?
GDB is a tool that has got a lot of sharp edges. If you think VI is bad, it's way, GDB is very painful, but it has really good tool chain to solve these types of problems. When you ran your code and it did core dump, right? Get a core dump. Well, you can actually use the debugger to find out why your code did the core dump. And trust me, that's where the big bucks are. You get to fix other people. They made bad code and they can't fix it. And you can use the debugger and fix it. There's also debuggers in your, how many of you use the debuggers in their browser? A couple of you? Wow. You folks have lots to learn now. Okay. These developer tools, there's a debugger in there. And you can actually debug your web page. You can actually change your web page if you don't like it. You could be sneaky, but it won't change it on the server. It just displays how it's rendered. Okay. But this is what happened, you know, well, with all our layered software. One of my students is working over Opportune. He's an Amazon cloud architect. And he's known about the company saying, where's the logs? Where's the logs? Where's the logs? Because if you don't have logging, you can't fix the problem. So the problem with the layered software that we have is you have logs that are written on the server. You have logs that are written on the client. You have logs that are written somewhere else. And there's no such thing as universal logging, which would be nice. But those logs point to what failed. And then you use the debugger to find out why. Okay. And that's that one. Okay, I do want to show you. Now you're saying, okay, why am I learning this? Why do I need to know this? Well, this I think is something that will come to a future near you. How many have heard of WASM? No. Any guesses?
Cloud service?
Yeah, it's basically web assembler. The stuff, this tool right here, this is written in WASM. Kind of, sort of. The guts of it are. And what is the WASM? Well, just as we compiled our C++ code into object code, and that object code runs. Do a Google search on WASM and say, getting started with WASM or something like that. Something fun and easy. All right. what is this doing? Well, this is pretty cool. Here's what it is in C, and this is what they call WAT. And this is what they call WASM assembler or assembler text. And then the Firefox assembler. Just as we have object code that runs specifically on a Raspberry Pi, and we have object code that runs specifically on an Intel machine, we can run WASM in any modern server. And the world of JavaScript is lots of code, lots of code. Well, now when you're using this WebAssembler, you can write code that actually just runs in your browser. This is I think it's going to be the future, because as you look at your notebook, the operating system, what do? You turn it on, you spend almost all day in the browser, right? Right? So if your browser's running WASM, who cares what operating system you got? That's where it's going. You won't need operating systems as we know them. The Chromebook is kind of a good way to see where the future's coming. Chromebooks have their place. Can't do a lot with them, but you can if you get the right kind. But this WebAssembly stuff is assembler, like you're learning in this class, but it's for the web. And this is super high-end, super fast stuff that will be coming to a future near you. Now, this article is written on why WebAssembly belongs outside of the browser. Well, now you have a universal assembler, so you can run your universal assembler on your cell phone, on your computer, on your clock, any embedded system. That's something you might want to keep an eye on, because this stuff is in your future. You may not even know it yet, but it is, okay? And it gives you the history of it and how it works and what it's doing. WASM solves a lot of problems that were introduced by JavaScript, and then PHP, if anybody remembers that, the hack programming language that Facebook uses. They've got their own specialized version of PHP. I'm not a big fan of PHP, but it does serve a purpose. It's kind of painful at times. Okay. So these are the kinds of things that you got to go learn, because nobody's going to teach you in school. Okay. So I'm giving you opportunities to go click on all those links and see what they do. I put them there for a reason. There's a lot of links to scroll through. Okay. And there's your VI and then the bash programming. Okay. Now we're going to have some fun with, this is an actual online GDB. There's my C source code. This is C. And I can compile it. I can also debug it. So if I run it, choose language. Okay, let's go with C. Exit code 0, and then the debugger. And it says, this guide on how to use the debugger. Yeah, we're going to be using tools just like that. Okay, on how to use the debugger, because the first thing you have to do is you have to set a breakpoint and tell it to stop. And then you look at the hex, and we'll be doing that next week for sure. Okay. So that's kind of where we're going. And then do your truth tables.
Are we only doing the and or gates or other gates too?
Look in Canvas. There's a list of them. So, and that's due tonight, right? You could spend some time working on it, get it turned in. Let's see here.
Mr. Phillips, what about the origami? Does this count for it?
No, if you can't do it, you can't do it. That's fine. I just wanted to see if anybody had the eye-hand coordination and they do origami. And that was just kind of fun. Use it to entertain your kids or your grandkids or whatever. That was just so you could get to this. You can actually see the truth tables when you're folding the origami.
So in the assignment, what we're turning in, we're not turning in anything.
No, yeah, you're just doing the gates. That's all you're doing. You're finding the truth tables from somewhere online and you're putting them together. Okay. And one of the things we might do is an adder where we put together a few gates to make it add.
My internet is,
That's tragic. That's tragic. You know what to do now. Simplify.
Just open it.
It's not on Canvas, there's-
But you can get to my website. So, yeah, just click on. So that's right. So you went to Canvas?
Yeah, I just refreshed it.
That's the whole resource.
For mine, we just have to do the. We said if you do.
But you can get the other websites. Oh, good. Listen, open it. Well, remember that long discussion we had about networking last week? That's what I found. You don't have an IP address, top bound. Check the cable underneath. There should be an Ethernet cable that's plugged into the wall and one behind the. Yeah. My hunch is it's disconnected. It's like it's unplugged. There you go.
That's it. That's what it, yeah, copy it down, take the picture, load it. Now you know what truth tables are. That was the whole point of the exercise. Okay? And with these truth tables and gates, we will see how they fit together and do other things with them, but not a lot. Like I don't get into the Boolean algebra. I don't get into a lot of the details of the gates and how they work and all that stuff. We're gonna jump into the debugger and assembler and learning how to write codes. That was just from last.
Oh, it's on. Yeah, the keyboard's on.
To do screenshots on your computer in front of you, there's a print screen button. You hit the print screen and it will give you something like this. And then you do your screenshot, right? And you hit enter. And over here it says section. And there's a button down here. It's in my cut buffer now. Now, how do I make a PDF? Well, I go over there and I click on that little blue icon that looks like Word. And in my case, it's, I'm going to use the LibreOffice Writer. And then there's the Office Writer, right? And now I paste my screenshot in. There it is. Ta-da! Now I want it as a PDF. I click the PDF button. Boom, it saves it as a PDF. And then you just upload it. Just like on Windows. It's just different buttons. Okay. So print screen, open LibreOffice, which is a free version of Microsoft Office. Paste it in and then save it as a PDF and then upload it.
That's
Well, yeah. Now, if you click on the icon over here, now it's telling you what to do. Call it lab 1. There you go. And now it's in the document lab 1. Yeah, because what we did last week, we took the two hello worlds.
Trying to get off of here. Double main.
We're starting off. For what? For the origami, just upload the two tables. So the hello world was last week. Last week we copied, we did the hello.text. Remember?
Yes.
So go to the 273. Yeah, that's that one. I'll go back. And see where it says hello world. So that's one file, that's another file.
Okay, so then we take a screenshot of that.
Yeah, you can compile it. I want to see it run. I want the success of that is we compiled it twice. Right. Do the same technique. Yeah, and then take the top half. And then highlight. Right, let's copy. And then just alt tab. Control shift. Okay. Now Control C. And Now,
First day.
about that.
He'll submit that.
Hello world.
Yeah.
This is the compiler. That's the compiler. Copy that and paste it. Yeah. GCC is for C. G plus plus is for C plus.
Okay. And they are different languages.
Yeah, dude, I just use PDF.
I did the.
No such, now, when you did the. Yep, and you have to make it look the same. No, no, just sit up there. Would you call it?
Yeah.
Ta-da. That's it. We got it.
Where's the code that we get to the compiler?
For what?
That, the,
On his
Wow.
website.
What?
On his website.
we're at the website.
It says hello world
Yeah.
underscore.
Either RAD 1 or RAD 2, both of them have
Yes. Yeah, that's it.
That's good.
No. Just- Yeah. Okay, good. Oh, good, you got it working.
Yeah.
That was fun, huh?
And then this is fine, right? 'Cause I didn't know you did the screenshot. I was at home.
That's fine. It's just make sure you get them all, because I forget which ones I put in. So if you look in the lab, yeah, there we go, it's down to the horizontal. It goes and then, or not. Or not, yeah. Those are the only 6 gates we're uploading.
Those we could just use in this online, that should be
It's up to you. You know, it's like, here's an exercise that we will do later this semester. I will ask you to use ChatGPT to create an assembler program. And if you're not tracking with assembler, you will not be able to get ChatGPT to work. You have to know enough assembler to know if ChatGPT is lying to you. That'd be a really interesting. We'll see if we get that far.
What compiler did you use for that? What code compiler?
No, this isn't the homework. This is something different.
After lab 1, correct? Or
No, you do that one. I was just showing you how to do a screenshot. This has nothing to do with the lab. It was just showing you how to do a screenshot. Okay? That's all I was trying to show you. All right. So read up on GDB, because we'll be jumping into that with both feet. Now, but when you did but I want you to type in, look at the instructions.
Or not that, but.
Oh, on his RAD 2?
That one. See, this is what you. I want you to do that one. Scroll down. Do like that. Then I want you to explain
I'm gonna do this.
how you understand when the data is like.
Oh, we haven't seen it yet? Where is it in Canada?
Trying to let you know.
Not that I
Yeah.
This command.
Sounds like something that could actually be like, yeah, I did that. I know what I did.
Try to
Oh.
understand. This is the first step.
I know, we just did it.
Hey Robert, have you Hello World yet?
On this line.
That's what we're figuring out.
Nah, that's what we're doing.
Out of the-
Yeah.
Yeah.
This is the beginning point.
Yeah.
Thank you.
So we'll open some.
I think now we're.
No. Now we just turn it.
Yeah. Because when you do the, let me reiterate that. Let me reiterate this, folks. Let me obscure the obvious, okay? For this, what I want you to do is, we did this one, right?
Yeah.
Screenshot it. Then do this one. Screenshot it. And these two. But what you're going to do is you're going to explain to me these by just reading the assignment and paraphrasing. It's there. Because this is a combination of an instruction and the payload of the data. I just want you to explain that. Because this is a assembler, basically. Very stripped down, but because we have registers that we move data into and pull it out of, and we'll be using the debugger to actually look at the data in those registers. Okay. And we'll start with that next week. Okay. So you can probably run this on your Windows machine because the C source code is pretty generic. But I'll have a login for you on the Jeremy box by next week. So did everybody get added that needed to be added? Your silence is consent. Okay. All right. And
Okay. It's only 6. It's only for 7. You didn't say make a PDF or just, oh, that's what the PDF is. I just used the converter on mine. Inside and then you can save as PDF.
Yeah, you just press the export.
I can turn.
you can also take the source code that is from this. There is online compilers. So you can actually take that source code and say, hey, I want this to be C++. And then type in the code there. You can use an online, there's online compilers all over the place, okay? So I'm going to try that just to see what happens.
Where is so many more steps? That's what I was. That's what I wanted. Because they're separately from the CPP and the G++.
Yep, works. So you can take the code and use this one. It's called online GDB. And all I did was click run. It compiled it and I used the first C++ option. So if you don't have C++ at home or on your computer, you can use an online one, okay? So that will work. Did your computer start working?
Yeah.
Was it the cable? Layer one problem, yeah. Yeah. We will get into. You know what? I think that online, does it let you change architecture? I don't know if that's true or not. Oh, maybe this is. This is what we'll get to do. This is the code that we'll be learning how to read. That's assembler. And we'll be doing some assembler and with the debugger and learning the different thing, but you can actually pick what kind of language you want to do with anything. Wow. What of options.
Which ones will we be working with primarily? Just C, C++?
We'll do a combination of C and C++, because basically once we get it compiled and then we bring it up in the debugger, it doesn't really matter. The issue we're going to have is that when we flag it to be used in the debugger, we have to give it some additional stanzas to say, put the debugging information in my object code so I have hooks to look at it. Otherwise, GDB won't work. Let's see, do they have? No. Yeah.
I don't know if it's but I got a picture of it in C and it's C++ running. But if you want it running this in the terminal, that's something that it works. Or it's on my file.
Now you know.
Okay.
Yeah.
Yeah, we're using tools.
Type that in, let's program.
on the computer. But it's online.
Right. Yeah, because I mean, I did the WoW and we were doing it, but.
Yeah.
Yeah, well, the terminal, the way we did it on the terminal was the lab, but. That's fine. Well, I guess, the site that he showed was.
Do everything. See that list? Go down the list. Dash 5.
Yeah.
So when we're explaining each step, you just want us to like paraphrase what's being written next to the code.
I think it's this, like, this is what it is.
It's not like,
Hey, Mr. Phillips,
Yeah.
for entering things, of figure 8.5, it's the same thing for the 8 part. It's the same exact thing.
oh, I think I.
So we send it again.
So as you say it, it's like, okay, this is the one that's doing this and this. Okay.
Yeah.
That makes sense. This is very
You
simple.
might want to read the assignment.
Read this.
Rather than just punch in the numbers, you might want to read how it works. Because then you'll have an idea just like.
So I was trying to do the. It gave me a lot of error, so many errors that it actually is just like.
Let's see. What kind of compile is it?
This is just
Yeah, so this is the process, so you need to check this, like the debug.
Is that a minus?
Yeah.
minus 2.
Oh, you're using the percent sign as your prompt. Right. And then when you a ton of error. Use the flag space. Yeah. So if you do G++ and then type in Simpletron CPP and just hit enter. So it's giving you the same error. So you're going to have to do G++ and do a minus V, I think, for version. Oh, your C-Lang. Yeah, that C-Lang is a completely different compiler than this one. That uses a logical volume type. But do G++ over here with the minus V and see what it comes up with. So this is the GNU wrapper. And then you are doing C-Lang. There's some switches that we're missing. The C-Lang. The C-Lang has a zillion different flags on it.
Yeah. Would it be easier to just get like a mix virtual box going and then have it in there?
Yeah, it's a lot easier to do this stuff. Now, you can use Alpine. That'll probably work for you. But Debian would probably be a better choice because Debian gives you all the tools. Here, I don't think, try the G.
Oh, I'm actually having a problem with it coming through. I can't get the
So it's not found. So
I would need to do but I'm having
yeah, it's you're using APK space add and then just type in build tools.
Yeah, this is having an issue where I can't get my Linux shell to the internet. Like,
Look at what Flavor's saying.
so it's like I can't find anything because.
Oh, type in ISP space A. Yeah. Should just be IP. And it shows Ethernet, but there's no address. So you need to type in DH client. And then hit space. And then ETH. Yeah. All right, DHCP client. So this command, dynamic host control protocol client. I think that's what that. I think that's it. Because what we're trying to do is bind an IP address to your card, and we need to use HCP to do that. That's just, yeah, I can. That's it. But let's use Debian. Just download Debian 12, and you can load it up the same way. Are you on Fusion?
This is UTM.
What?
It's called UTM.
Really? What is this?
It's a Mac OS like specific virtual machine.
Huh, slick. I had no idea. It's new. And then, yeah, so there's, yeah, just Debian 12 is the latest. But it doesn't matter. Oh, really? It's already half built for you. That's
Yeah.
said a lot of time. Probably download image. You know, if you guys ever need to download big files, you should come to campus on the weekends. Their bandwidth is wide open on the wireless network, and you can download stuff really fast.
Yeah.
So, like right now, you're dealing with congestion with the Wi-Fi, because everybody in the room is probably connected to Wi-Fi. Yeah.
I would just. I'd actually. So really
Yeah. I'm trying to do that.
what you do is.
No, I.
So then you're gonna do so you first you can do this, and then do the cat kind of hello world dot CMD.
If you're looking for something to do, and you're all done,
And
look
then
at the GBB
compile
stuff.
it.
And how do you use the hello world? How do we compile it to put it in GDB? That's what we'll be doing next week. So, rather than me feeding you, jump into it. Okay.
It's
It's cool.
Yeah, yeah. Like, yeah.
Oh, it's called Build Essential. Build minus sign essential. And that gives you all the compiler tools and everything you need for Debian. Debian is a little more traditional, well, like these machines. Alpine Linux is actually designed to be stripped down and run on routers. And it uses everything inside of BusyBox. And BusyBox is one executable that has the most common Linux utilities built into it. And it's on most embedded systems. Like you can put BusyBox on a router and it won't take up a lot of room. That's why it's so small.
So you don't. Or you saying what? Yeah, I don't know. So I made the call, right? So I got, well, oh, you did I did it later. I see. Oh, well, that's just making a whole. So then
Also, code on my Mac, like do some of the thing we just did. Probably gonna have to redo it. If I wasn't doing it on my Mac, what would I use to code on? Write my code.
Like the compiler.
Yeah.
Well, look what he's doing. He's using something called UTM.
UTM.
Yeah. Is that comes with Mac OS?
$10.
Oh, it's $10, but looks like it works pretty well. He's doing a virtual machine of Debian. So he's basically firing up.
So now I'm putting the.
It's just the G.
So for the homework assignment, we need to go through and explain. For the homework assignment, we need to go through and explain for A, B, and C how it's working, how we got there.
Basically, because the numbers represent something.
Yeah.
And they're split. Just tell me how you absorb that. So does it? But you're gonna paraphrase it. You're gonna read the assignment, get the answer, and then just paraphrase it back.
So does it matter how incredibly accurate we are? It's just how we perceive what we're doing.
Yeah, 'cause this is the first step of getting into the assembler.
I wasn't sure if whether or not you needed to know exactly what line was doing.
No, you don't. No, as far as the source code and what the source code is actually doing. No, you want to know what the op codes are. The ones you type in. What are they? It's a combination of things.
Oh, yeah.
That's what we'll be doing next week. Jumping into the GDB.
Once paraphrase it, how we understand, it's not, he's the one who wants to explain what it is.
You also might need in utils. Utils with a plural S.
Yeah, because that's what he wants.
Maybe.
Because it says right
Yeah, when you type this stuff in, what is it?
Yeah.
So
what it's done is.
yeah, we'll type it in, signed in. And some of those integers have a command code. Some have data.
So it'd be like a 2 sentence.
You. The goal of this is not so much to get a, you understand it, and so you can build the next piece of the puzzle, which is going to be that's
So, okay. Okay.
For the lab, do you want us to screenshot what we do today? Put on it, or just
Yeah.
because I have like the explanation of the first two, or
Mhm.
my understanding of the first
Mhm.
two and the last two digits and what they're doing.
Mhm.
It'll just be the screenshots and this.
Yeah, you can interface it with that, and because what you're going to do is type in this stuff and then see what it does, and then explain what this, like, why is a 43 a halt, or is it the 00 that's the halt? Because this is a combination of an instruction and data. So, and that it's all explained in there. And you may have to look at the source code, because there's more data of how this works inside the source code. So when you look at the go back one here, if we look at the C source code here, there's some instructions in here. It gives you what you're going to see, so you can actually use the code to tell you what's going on. And you don't have to be a C++ expert. I'm not expecting you to understand all that, but the idea of, okay, we're putting in these funny numbers, it's doing something. Explain it to me. Yeah, that's it. It's not.
I think I understand what's doing. I guess I'll just like do an example of why this number.
Yeah, it is like for example, they have read 10.
Yeah. Okay.
Right. That load is what?
Those 20.
Yeah, add is 30. Does that look vaguely familiar?
Yeah. I had a question. I think I'm understanding this, but what are the zeros? Are they just
The 0? That's what they're zeroing out the register. So when it does its thing, it can put the answer in the register. Because remember when we did this very first one, the last thing he did when we put in the 999, notice it says variable A, B, and C, but it's zeroed out.
Yeah.
But it's already stored in the register. That's kind of what we're looking at.
Oh, okay, because it's writing to this.
And this is the actual address.
Yeah.
Of that information.
Oh, cool. Right.
And this will make more sense as we spend more time with
It's
it.
definitely a little crazy.
Well, yeah, it is pretty obscure.
Yeah.
I admit it. It's obscure, but it's
I'm sure I can figure it out
yeah.
eventually. But yeah. Thank you.
No worries.
So, yeah, we're paraphrasing.
So what do I do after this one?
So you go to basically what would I do now? It's like
Did it work?
I'm having some technical difficulty. It's like saying I don't have permissions.
Oh. The Debian or the UTM? Oh. The Debian does not install it as UDO by default. So
I'm getting to.
do you have a? Oh, that's a different.
Yeah.
Okay.
yeah.
That just needs to be.
Yeah, so you just basically just like put the codes. Screenshot.
But it's not, so you downloaded it and it started to install.
So it's
And then it created basically a virtual disk.
Yeah.
And then from there it died.
Yeah, so now it's saying that they can't.
Oh, you're uploading ARM. Is that what you wanted? Did you have an ARM chip?
Yeah.
Okay, then that's what you want.
Yeah, that's what it was. I was doing XA.
So- So there you go. And now, and do Control T. I think that works here.
Control all. Can you- Yes, yeah, just right click and see if it brings up. It's what it's doing now is it's setting all the defaults for the Windows. But yeah, Windows stuff. I didn't realize when I got the Apple silicone chips that it was gonna make life so much harder. Yeah. Isn't that fun? And then, you know, Google's got their TensorFlow and, you know.
It's cool. It's a cool new thing.
Yeah,
It's too new.
yeah. I get it. So if you notice in the source code, you can get some more answers. Notice it says read 10, load 20. That matches with the code you typed in. Use the source, Luke.